So the idea of solving simultaneously, I suppose the most common way of doing it is what we call the elimination method, where the idea is eliminate a variable, hence where it gets its name from. Then you go and solve for the other variable, and then substitute back in to get the eliminated variable. Basic idea. So let's just look at a very simple one. And of course you say, so, well, the simplest way of doing it is making the coefficients of either the x or the y, it doesn't matter which, make them the same. So I've rewritten mine. I'm going to multiply the first one by 2, second one by 3, thus making the coefficients of y the same. Makes it very easy to eliminate then, because I can just do a subtraction. I'm actually going to subtract up, so I get a positive number. 15 minus 4 is 11, 9 minus 42 is negative 33. Okay, so x is negative 3, and then we sub back in, and we get that y is 9. Just a note, I guess, on how we would write the answer. The answer to this is x equals negative 3, y equals 9. It's not the coordinates negative 3, 9. Now, okay, if we were solving a coordinate geometry question where this was the intersection of two lines, in that case, yes, the answer would be a set of coordinates. But remember, answer the question you're being asked, not the one that you think's being asked. I guess the other way of doing it is simply via some sort of substitution, because something like this we can't eliminate, because technically we've got 4 different pronumerals there. Because x is a different pronumeral to x squared, and y is a different pronumeral to y squared. So in that case, what we do is we try and make y or x, doesn't matter which, the subject in one of them, and obviously the linear equation is going to be the easier one to do that in. So we'll make y the subject in the first one, substitute it into the second one, and in this case we end up with a quadratic equation. Oh no, 205 doesn't divide by 3, does it? Oh, that's annoying. Otherwise it would have been a nice easy one. So multiplies together to give 615, adds together to give minus 56. Oh yeah, okay, I got it. That factorises to be 3x minus 41, x minus 5, quite nicely. So 2 possibilities, which also means there's 2 possibilities for the y. But be careful how you answer it. Make sure you group them correctly together. So it's x equals 5, y equals 4 is one possibility. X equals 41 on 3, y equals minus 40 on 3 for the other possibility. If this was a coordinate geometry question, what we're basically looking at is where a straight line, 2x plus y equals 14, intersects with a curve, x squared minus y squared equals 9. Anyone know what that curve looks like? So it's x squared minus y squared, so it's not a circle. What did someone say, parabola? Not a parabola. It's not a sideways parabola. No. Hyperbola. It's turns out to be our sideways hyperbola. So it makes sense then that you get 2 points of intersection. That would make sense. Now, of course, most of the time we just do boring ones, where it's just 2 equations, 2 pronumerals. But any time you've got the same number of equations as you do pronumerals, assuming they are distinct equations and one's not just a trivial multiple of the other, it should be possible to solve. So I've got 3. We just have to rewrite it. So, that's what I just said. Anytime you have the same number. So what we're going to now do is eliminate one of these equations. We'll end up with 2 equations, but we've got to eliminate the same variable from both. So I'm going to match up the first one, I'm going to multiply by 2, and match that up with the second one. That will allow me to eliminate the x quite nicely. And we get an equation 7y minus 6z. Now I just need to pick another pair, doesn't matter which pair, but I'll also eliminate the x from that. So if I now multiply the first one by 4 and match it up with the third one, we can eliminate the x from those 2. And we now have 2 simultaneous equations with 2 pronumerals, which we can do the standard way. And so I'll make them both 6z and then we'll go and eliminate the z's, and eventually we get to y equals -2. But now we should be able to track back and get all the pronumerals. So if y is -2, subbing that back in, we get z is 4. Then subbing those two back in, we get x is 3. And so there's my final solution. What you've actually just solved there is 3 lines in a 3-dimensional space and the points where they meet. If you were to talk about geometry on that one. Okay, that'll do. So 1H.